Last time I drew a sketch of Jupiter, and for the most part I'd say it turned out pretty well. So this time I wanted to increase the challenge a bit. This time I'll be drawing Messier 42, otherwise known as the Orion Nebula. Otherwise known as... No, I think those are the two main names. The Orion Nebula is around 1,300 light years away, and it is considered a stellar nursery. In other words, it is a cloud of gases where lots of stars form. This cloud of gases has a mass of around 10,000 suns, so it's pretty dense with gas to say the least. A lot of people often wonder how telescopes are able to get these crazy powerful images of deep space objects. What's actually really interesting is the raw image of the objects usually doesn't look like this. This takes a lot of really advanced image processing to pull off. Even with incredibly advanced modern space telescopes, such as the James Webb Space Telescope, the images don't come back colorful immediately. The images actually start out very dark when they originally get sent back to NASA from the James Webb Space Telescope. It then takes a ton of image processing as well as usage of various types of data such as infrared data from the James Webb Space Telescope to obtain that colorful image. There are around 3,000 stars in the Orion Nebula region. These stars include massive and smaller stars. The more massive stars are actually one of the reasons why the Orion Nebula has its shape. The gravity of the stars actually alters the arrangement of the gas clouds just a little bit. Drawing a nebula is a bit of a challenge because, as opposed to a planet like Jupiter, where the sketch can look very crisp and sharp with a lot of edges and dark portions that blend together, a nebula has to be sort of on the softer side since it is a spread out large amount of gases. The sketching also has to reflect the fact that there are various colors all over the place. So that can be done with shading differences, but it won't be perfect. The shading is sort of a must-have for this sketch, because without proper shading, you really can't get the right form of the nebula. Around the bottom of the nebula, you may see some fainter stars that are a bit red in color. These are myriad brown dwarf stars. They're nowhere near as hot as the brighter, larger stars, and according to NASA, they're sometimes called failed stars. This is due to the fact that they cannot sustain nuclear fusion in their cores the way a normal star would. Near the center of the nebula, you can see some really bright stars all collected together. That is the trapezium cluster. The trapezium cluster consists of 4 known primary hot stars. This group of 4 stars is producing so much ultraviolet light that they have carved this cavity in the Orion Nebula and are directly disrupting star growth. The darker portions of this sketch really help to emphasize the details of the nebula. The center is a good example for this. The center is very lit up in the photo from Hubble of the nebula, so I used darker shading in the sketch nearby it to emphasize the bright contrast. It's also pretty lucky that there is literally darker clouding right by the brighter region that I was able to use for this. The Orion Nebula actually has a lot of interesting history. Since it is the closest large stellar nursery, it is the most clearly visible nebula with the naked eye. So a lot of cultures over the course of human history have seen the Orion Nebula. The Mayans in Mesoamerica actually referred to the Orion Nebula as the cosmic fire of creation. This name is ironically pretty accurate, since it is the location of a lot of star formation. So it's literally a spot for creation in the cosmos. When we look at a nebula, especially one that's super bright like the Orion Nebula, we may be wondering, how does a nebula like this get this bright? And that's actually due to the stars in the nebula. According to Rob Gendler, the illumination takes two forms. Parts of the cloud simply reflect starlight and are so-called reflection nebulae, while in other areas, gas in the cloud is also excited by the light of nearby stars, absorbing and re-emitting energy just as happens with the gas in a neon sign. When you look at something like the Orion Nebula, you may immediately think, oh man, that thing has to be just like ancient. It has to be billions of years old. It had to have been one of the earliest objects in the universe. But what's actually interesting is, according to current research, the Orion Nebula likely formed in the past 10 million years. That's million with an M. In other words, the Earth is likely way, way older than the Orion Nebula. I hope you enjoyed watching this video, seeing this sketch, and listening to some facts about the Orion Nebula. If you did, please like and share this video and check out some of the other content on the DSpock channel. There are tons of YouTube shorts on this channel with science discussion, as well as other long-form videos discussing astronomy as well. If you'd like to see another sketch, check out my video of me sketching Jupiter. Please subscribe, leave a comment, like the video, all that is appreciated, and I'll see you in the next one.